Hello everybody, Gliderman here. Today we're going to be looking at structural. So basically, it's the very core of a circuit. So basically everything is built out of XORs, ORs, ANDs, NORs, whatever, NOTs, and that's what everything uses to define circuits. So let's take our example that we have here and let's create a new circuit. For this, I'm going to be creating a temporary variable, you can almost call it, if you're familiar with other programming languages. But essentially, what we're going to create is a wire. And a wire can be used similar to an LED or a button or an input or an output, except you can both read and write to it, and it's internal, so it doesn't connect to anything outside of your circuit. So let's create just a wire, and we'll call it B1 and B2. So that's going to be our wire. Now you cannot assign that here, or at least I don't think so. So what we're going to do is be using our structural. So as you can kind of guess by the name of this, I want to AND button 1 and button 2 together. So what I'm going to do is I'm going to do and you're going to see that highlights there, or colorizes it blue. And then I'm going to make it the first variable, which is the output of the AND gate, B1 and B2. Then put in a comma and a space. So from here, you can put in as many other variables as you want, and it will AND everything together and make it go to this one output, which we have as a wire. So for this, I'm going to do B1 and B2 as the AND. The order shouldn't matter because it's a basic logic gate, and I'm specifically going with the B1 and B2, and in fact, I'm going to use it like they're an array here. So I'm going to put the square braces around it, or square brackets, or whatever. And the reason I'm going to do that is so that I can create another wire, which we'll do up here, a wire, and it will be 2 down 0, and it's essentially going to take the buttons, and I'm just calling it B for right now. I'm going to take the button and I'm going to invert it and connect it to the B, or all of the buttons, that is. So I'm going to assign B to not with the tilde there, button. Now this is a perfectly fine statement. However, you can punch these in and tell it I want to do these specific indexes. They should be basically equivalent. It's really up to you, but I'm going to be punching them in this way. So it's assigning to this, and that is flipping it there. So we've got this wire that's ANDing button 1 and button 2, and then let's OR it. So we'll actually create another wire. We'll call this wire just output for, actually we can't call that output. We'll call it LED output for right now. And then we'll put in an OR logic gate, and we'll make the OR's output LED output. And then just like the AND gate, however many variables you punch in, that's what it will put in there. So let's put in B1 and B2. So we're taking that wire that we had from up here and we're punching it into here as the output, or as an input, and we're going to also use B0, and then, oh, that's not a 0, and then put a semicolon on the end there. So now we've got our LED output wire there, and now we can connect that to our LEDs. So let's assign LED G0 to LED output, like that. Let's save that, and let's get that compiled and onto the device. Okay, so now our project is done compiling. You can see this time it took 29 seconds. Here it's also using one logic element, which you may find is interesting, even though we have an AND gate and an OR gate and a couple NOT gates. Somehow it managed to do just one logic element. A logic element is not necessarily just one component or anything like that. It's a complex circuit, and there just happens to be 15,000 of them. So anyway, that's compiled, and let's open up the programmer. Let's add a file. Select our tutorial.sof, click open, and click start. So now we've got the 3 buttons. This is button 0, so if we press that, you can see with our OR gate that works out nicely. If I press either 2 or 1, it doesn't do anything, but if I press them both together, it ORs them together. If I let go of 1, it does that all nice. Compress these 2, it'll still go because of this 1 here. And of course I can press all of them and it's on. So that's a basic introduction to structural Verilog. There are a number of other different preset ones like and, or, not, and all of that kind of stuff. You're free to check them out. My recommendation is actually not to do structural. I know I just made a tutorial on how to do structural, but my recommendation is actually not to use it because it can lead to huge programs. Particularly, really anything more complex than just something like with 1 or 2 logic gates. Because you need wires running between all of them, and then you got to keep track of all of your names and make sure that they're all correct. And any changes are also hard to implement. But that's just me. You're free to use it. You can use it pretty easily for simple things like this. But yeah, that's how you use structural Verilog. Thanks very much for watching, and be sure to tune in for more tutorials.